Good morning, CP Math Studs. It's good to see you. Hopefully you guys are staying healthy and safe and getting your algebra and algebra 2 stuff done here for CP Math. You guys did a great job on Monday's assignment doing today's elimination, doing substitution. So I just wanted to go over number 6 with you guys from that homework assignment. Because that seemed to be the one that gave people the most trouble, and just basically because it didn't come out to nice whole numbers. So I'm going to go over that one with you, and then we'll get into elimination today. So this one already has x alone. Remember, when we do substitution, we want to get one of the variables alone, and I was telling you to get a variable that had no coefficient in front of it. But that first step has already been done for this number 6. X is already by itself. So I'm going to take what x equals, this 3y plus 15, and substitute it in the other equation for x. So this becomes 8 times 3y plus 15. And then remember, plus 3y, we just substituted for x, so that 3y is still there, equals -7. So this is what it looks like. So we're going to distribute. 8 times 3y is 24y. And 8 times 15, would be 40 times 5, 90. Hopefully my calculator that God gave me is working. Plus 3y equals the -7. And then I'm going to take the 90 to the other side. Wait a minute, that's not 90. My calculator is not working. I think that's 120. Yeah. Sorry. So, mistake already. I was just seeing if you guys were awake. Let me get this so I can get my eraser out and change that to 120. Sorry about that. So subtract the 120 from both sides. So I get 24y plus 3y, 27y there. And that's -127. And then divide by 27. Sorry about that. So I'm just going to use the calculator for that, see if we can reduce that fraction. I think we can. All right, so -127 divided by 27. And that's the decimal, which some of you got. I like to use a fraction, and it won't reduce. So we're just going to use that. And then we're going to take that so that's what my y is, and put it in here. All right, so we're going to x equals 3 times -127 over 27 plus 15. So go back to my calculator and just go times 3. And then plus 15. And then I change it to a fraction. So hit my math button and enter twice. And it's 8/9. Oops. Let's get that to be an 8. ninths. Not the best at using my mouse to draw my numbers. So it'd be 8 ninths for my x value. Why do I keep doing that? 8 ninths. And then negative 127 over 27. Again, if you wrote it as a decimal, that's okay. So just want to go over that one with you because some people had a little bit of struggle with that, it looked like, on your homework. All right, so again, that's substitution. Get one of the variables alone. In this case, x was already alone. Substitute for that variable in the other equation, and then solve for whatever you have, x or y, and then plug back in to find the remaining one. All right, so today we're going to solve system of equations by elimination. So in this situation, we want to write our equations on top of each other and make sure everything lines up. So I got my x's first, my y's, my equal to signs, and then my constants on the other side, and everything's lined up. So then I want to eliminate one of the variables. So when you eliminate one of the variables, you want to look at the coefficients, all right? And you want to look for coefficients that are the same. So if you look at the x's, they both have a 2 in front. One's a positive 2, one's a negative 2, okay? So we're going to eliminate the x. If the y's had something the same in front, then we would eliminate the y's, okay? So that's the first thing I always look for, is if I can eliminate right away, okay? And the way we eliminate is by adding or subtracting. So I always just say when the signs are different, it's supposed to be a D, different signs, like this case, got a positive 2 and a negative 2. We add. Same signs, if they're both positive 2 or both negative 2, we would subtract. So S for same, S for subtract. So if these were both positive 2s or both negative 2s, I subtract the two equations. But since the signs are different, and I'm just looking at the signs of the coefficients, positive 2, negative 2, they were different, so I'm going to add these two equations. So 2x plus a negative 2x will cancel. Negative 5y plus 8y is a positive 3y. And negative 5 plus a negative 58 is a negative 63. And that's my equation now. I eliminated the x's. So we divide by 3. And then we'll have our y value, which will be negative 21. Okay, but that's only halfway. Remember, we have to find what x value is as well. Remember, when we solve a system of equations, we're looking for the x and the y value that works in both equations. So I'm going to take this negative 21, and I'm going to plug it into either one of the equations. I'll just go ahead and put it in the top one, but it doesn't matter. This is your choice. So this is 2x minus 5 times, I substitute the negative 21 in for y, and I get equals negative 5. All right, so that's 2x plus 105. Negative 5 times negative 21 is a positive 105. Equals negative 5. So then I'm going to subtract my negative, or subtract 105. Take it to the other side. I'm going to solve for x here. I get 2x equals negative 110. And then divide by 2. And that's negative 55. So my answer, my ordered pair, is negative 55. Whoa, that was ugly. Wow, let's try to redo that. Negative 21. I got to relax. All right, sorry, so sloppy. All right, so that's using an elimination to solve a system of equations. That's our first example. Here's our second example. Okay, let me move this third example down a little bit for you. Go back up to number 2. Okay, now in this situation, none of the variables have the same coefficient. I got a 3x, 2x, a negative 4y, a positive 5y. So we've got to make them the same first. We have an extra step we have to do this time. Okay, so it's your choice here. You can make the x's have the same coefficient or the y's. I'm just going to do the x's. All right, so usually I just take whatever the bottom coefficient is and multiply it by the top one. Oops, I need to get my pen going. So I'm going to multiply the top equation by 2 and the bottom equation by 3 so that I'll have a 6x for both equations. Okay, so 2 times 3x is 6x. 2 times negative 4y is negative 8y. Again, you're going to multiply 2 by everything. And 2 times 10 is 20. Both sides of the equation by 2. And then 3 times 2x is 6x. 3 times 5y is 15y. And 3 times negative 1 is negative 3. So that's what it looks like now. Make sure you distribute the 2 through everything in the 3. So I got these 6 x's. Like we said, the signs are the same. All right. 6x, positive 6x. So I will subtract because the signs were the same. 6x minus 6x cancel, eliminate each other. So that's what we wanted. Negative 8 minus 15 is a negative 23. Y. And 20 minus a negative 3 is like adding 3, so that's a 23. And then I'll divide by negative 23 to get my y value. And a positive 23 divided by negative 23 is a negative 1 for my y value. All right, so we're half done. So I'm going to substitute that into either one. I always go to the original ones, not the ones I changed. And this time I'll just go to the second one. So I'm going to put it in for the y there. So I'm going to go 2x plus 5 times negative 1 equals negative 1. Again, you could do in the top one too. This is, again, your choice. So 2x minus 5y. Minus 5 equals negative 1. Add 5 to move it over. And then I get 2x equals 4. And divide by 2. X would be 2. So my answer is 2, negative 1. When I put 2 in for x and negative 1 in for y in both equations, I get a true statement. All right, so we solved that system of equations using elimination. All right, one more example. Hopefully this is making sense to you. All right, so this one, I got nothing in front of the x, or a 1. We just usually don't write it. And a 3 in the bottom. And I have a negative 2 and a negative 6. Okay, so let's go ahead and make the y's the same this time, since I did x's last time. Again, this is your choice. It doesn't matter. So since 2 already goes into 6, I'm just going to multiply the top by 3 and then those coefficients in front of the y's will be the same. So 3 times x is 3x. I'm going to put it right under that one. And 3 times negative 2y is negative 6y. Oops. And then 3 times 2 is 6. So I'm looking at, I made my y's the same this time, and they both are the same signs like this last one we did. So when the signs are the same, we subtract and see what happens. Well, 3x minus 3x, they eliminate each other. Negative 6y minus a negative 6y is like negative 6y plus 6y, so they eliminate. So I get 0 on this side because both of those were eliminated. And then I got 6 minus 6 here, and I get 0 again. So everything eliminated, and I got a true statement. The other day when we did substitution and we got things like that happen, we got a false statement, like our x's and y's got canceled out. After we substituted, we got a false statement. We said there was no solution. Well, if this happens and we get a true statement after this, everything gets eliminated, no x's or y's, that means we're going to have an infinite number of solutions. So we call that an identity. So infinite solutions. So whatever we pick for x, then we can solve for y, and we'll get the right answer in both equations. All right. So sometimes that's going to happen, just like for substitution. All right. So again, going over what we're supposed to do, we want to make the same coefficients. If the signs are the same, we would subtract. In this example 1, the signs were different. That's why we added them, and we eliminated the x's. They were already the same to start. And number 2, we had to make them the same. I made the x's the same, so I multiplied the top by 2, the bottom by 3, and got 6's, and then subtracted because the signs were the same. And number 3, I got the y's the same, so I multiplied the top by 3 because 3 times 2 is 6. I put it underneath there, and what happened here, everything was eliminated, and we got a true statement, so we had an infinite number of solutions instead of no solution. All right, so that's solving a system by elimination. I hope that's pretty easy for you. I'm sure it is because you guys are just so smart. So this next slide is your assignment. Page 799, 22 to 32 even. I'll take a picture of it for you and post it on Canvas. That's due tomorrow, April 9th. You don't have to do any schoolwork on Friday. That's Good Friday. And Sunday is Easter. So you guys have a great Easter. I hope you guys are feeling well and staying safe and healthy and doing your social distancing. I hope all your families are doing well. And just have a great day. We'll talk to you soon. I'll see you next Monday. Again, on office hours, they changed it up a little bit. So for CP, it's going to be 12:30 to 1 o'clock on Mondays and Wednesdays. And then on Tuesdays and Thursdays, 8:30 to 9 like it was before. But instead of having a full hour on Mondays and Wednesdays, they've dropped it because it's been hard for people to get on Canvas conferences because of so much traffic on the internet. So if you have a question or concern, email me. And if you need to talk to me individually, just email me and we'll set up a time where we can conference, or I'll just call you on my phone and help you out the best I can. So again, have a great day, and we'll see you soon.